Welcome back. In this video we are going to continue where we left off, which was at control flow, where we implemented the if and else construct. Now we're going to look at logical operators like the AND or the OR operator. So to do that, we look here at how the grammar changes, and now assignment will go into the logical operator statements, and instead of directly into equality. So that will change the parsing, but first let's add a new expression type. Zoom out a little bit. So it should be here. We can put it in here so it's in alphabetical order, and it should have a left expression and an operator and a right expression. And now let's fix up the parser. So we'll go into assignment. Let's try that again. There we go. So let's see. So now we, instead of calling equality, we need to call the OR, and everything else should be the same. So let's see what will happen. First it will try to pass something, and then we'll see if there's an equals token, and then it will try to, if there is an equals token, it will try to pass the right hand side, and then it will look at the expression, and if the expression was a variable name, then it performs the assignment, otherwise it throws an error. Okay, so that's correct. Now let's implement this thing. And again, if we look at the grammar here, we need to look for an AND token, and then if there is an OR token, then we have to do something more. So we can just look here. If we match an OR, then the operator is the previous one, the right side is this. And it's okay to call back into AND because here it just stands for some generic expression. So we don't call back into OR because it's kind of already we already have an infinite amount of ORs here, and we don't call back up to expression or assignment because we don't really allow having an assignment inside an OR statement. Great. So interesting. Just make it mutable. I think that should work. And now we need a logical operator with left side equal to the previous value of expression, and it has to be box new, has to be boxed, and an operator equal to operator, and a right side equal to a box from right. And once we've run through all possible expressions, then we return that one. Let's check it. No method named and that is okay. Right, and we need to wrap it in okay as well. So let's try that one. Before we go to file, let's try this. Right, so now because we added the logical type to expression, then now we get some compiler errors that we're not matching exhaustively, which is good, of course. So let's just go fix that now. And we will put it here. So we have a left operator, right, and then we need to make this Lisp-like thing. So this should be the operator and then the left and the right. Operator to string. Let's see if that even compiles. And now it's talking about down here and evaluate. So let me do this so it looks less confusing. So actually we're getting a little bit ahead of ourselves relative to the book, but whatever. Let's just try. So we kind of have to match on the token type, I think. And if it's an OR, we have to do something. If it's an AND, we have to do something. And if it's an OR, we have to say let left-hand side true equal to left dot evaluate with this given environment, and then we have to say is it truthy, which I think we defined. Yes. And then we have to say if the left hand side is true, then we just return true. Otherwise we will, well, let's do this. Otherwise we should return the right hand side evaluated with this environment. And these things can return an error, so let's put error unwrap here. Great. So now we have implemented this short circuiting behavior that we want. So we evaluate the left hand side, and if it's true, then we don't do anything with the right hand side. But if it's false, we have to check the right hand side to determine whether the OR operator is the OR expression is true or not. So we do the same here. And now it looks it's a little bit weird to call it left hand side true, but whatever. If it's false, then we can return false already because of the way the AND works, and else we have to evaluate the right hand side. Great, let's see how that works. Alright, so these guys have to be wrapped in OK. And these don't need to be unwrapped because they're already result type. There's some kind of error. Unused result. That must be... For more information about this error, not sure what error it's talking about, because... But it's an interesting thing nonetheless, so let's... Right, so we need to do this. Okay, so I think we were here implementing AND. So let's see. First, we look for an equality. Then we look for an AND. The right hand side, we make this thing mutable, and we make an expression, rather logical, where the left is equal to box on that, operator is operator, the right is a box around that. And finally we return it. So I think that's more or less it. There is an error because I keep forgetting that we have to do that. They should almost implement like automatic wrapping in OK, but whatever. Let's okay. It wants us to qualify like this. And that made an error. Somehow. Okay. Line 202, match operator. Okay, yeah, I mean, a good point. So if it's some other token type, then we need to make an error that says invalid token in logical expression. Okay, oops. Let's try to run it. So now we should be able to say something like, actually what happens if I just do like disembodied statement like this? I didn't like it. I can't remember if it's... Okay, so it's lowercase. So let's say a equals true or false, and then we can print a. It's true. It's printing it like it's a string, which is a little bit weird. Let's fix that now. It's not here, it's in the interpreter. It's kind of funny. Let me try something. So no. About this. Same thing. Okay, so what is expression, or rather what is value? It is, what is the print statement? It has an expression. Okay, so let's go back into expression and then basically we need to fix up what happens when you call toString on a string value. And it just clones it. But what we want is it's gonna be a little bit of weird. Let's do something else. And we can probably get away with just saying X here. Great. Okay. So it's a bit of a digression, but whatever. Okay, so here's an interesting thing that so the way I just implemented it right now is we will return. It's starting to look very horrible to look at. Anyway, so if the logical operation is true, I'll return true, or rather if it's truthy, I'll return true, otherwise actually here we should, but whatever. So it's for it to be consistent, probably we should return this. But now he's saying something interesting, which is that we are not going to return true or false. We're just going to return a value that has the right truth value. So instead of returning true here, we just return the left-hand side. And then this is correct. And the same here. Let's try to run it. So now there's an error. So it wants a, so let's say left-hand side value. So left-hand side value environment. And the same thing here. Fantastic. So the point kind of is that if we have an OR, like if we have something like 2 plus 4 or 2 equals 3. Then it will evaluate this, it will give 6, and then it will look whether that is a true value, a quote-unquote true value. Because it's an integer and it's not 0, it will say it is true. And then rather than returning true, we'll just return 6, which is a truthy value. So that means that we should be able to do things like this. We can say, 2 plus 4 or false. And then if we print A, it should be 6. Yeah, exactly. And we can say this is true and true. And then if we print B, so when we have the AND, it will always return the last thing. So actually we should try something like this. Yeah. That is kind of nice, I guess. So he's actually doing the exact same thing here. But I think that's it for this video, and the next video we'll look at while loops.